So today we're here to talk about our project. And for our project, we decided to add different amounts of iodized salt to water and see if the boiling time changed depending on how much salt we could add to the water. So our increments for independent variables, we had 0 tablespoons of water, 3 tablespoons of water, and 5 tablespoons of water. And we did each amount of tablespoons 7 separate times to make sure that no mistakes were made. And we found that in the amount of salt in the water does affect the time it takes for the water to boil. So for our experiment, like I said, we were measuring the effect of the amount of salt on water. And so the first thing we did is we got a hot plate and turned it to 1,000 degrees. And then we put a pot on top and put 2 cups of sink water in. And then we had slips of paper to randomly generate how, if we were doing 0 tablespoons, 3 tablespoons, or 5 tablespoons. And we went through the picking random numbers until we did each one 7 times. And we would have it count as bubbling when bubbles appeared on the surface of the water on top.
So based on our findings, here we have our mean boiling times based on the tablespoons of salt added to the water. And we see that the highest mean boiling time is for 5 tablespoons of water. Here we have our ANOVA findings. And we see here that the F value shows the difference in the findings is very significant and wouldn't happen in random conditions because it is so large, it being 210.11. And with a small p-value such as this one, this shows convincing evidence that there is a difference in mean boiling times in water based on how much salt was added. And with confidence intervals, these confidence intervals allow us to approximate with 95% confidence the differences in boiling time between various levels of salt. Since all the confidence intervals fall completely below 0, we are very confident that there's a difference in mean boiling times between 0 and 3 tablespoons, 0 and 5 tablespoons, and 3 and 5 tablespoons.
tablespoons of salt and amount of time in minutes that it took the water to boil. As you can see in this table, we established a correlation of 0.9576 between the tablespoons of salt and the boiling water. As you probably already know, this is a very, very strong correlation. Okay, so for our regression findings, firstly, we found this scatter plot with this regression line superimposed over top of it. You can see that the R² value for that regression line is 0.9171, which is a very strong correlation. It means that 91.71% of variability in our findings for boiling time was accounted for by the salt added to our water. Then you come over to our parameter estimates. We found that the Y predicted value for the equation was 3.848 plus 0.271x, which means that if 0 tablespoons of salt were added to the water, we would expect the boiling time to be 3.84 minutes. But for every additional tablespoon of salt added to the water, we would expect the time to increase by 0.27 minutes. So when doing our assumption checks, for ANOVA, our assumptions were an independence of samples, a normality of the distributions, and an equality of variances. We did have independence of samples, and we did have normal distributions as indicated by the linearity of the scatter plots, but unfortunately our equality of variances assumption could not be met because our F value was so high. Similarly, for our regression assumption checks, the linear relationship was met, the populations were normal, the independence was correct, but the equality of variance was not.
Some things that could be used to make our findings more reliable would be more varying levels of salt added to our water, such as 7 tablespoons or 10 tablespoons, just making sure that the data we received from each varying level would match with our results section. We could also try and use distilled water just to make sure that the water from the sink played no effect and no part in the boiling time of the water, just making sure we had the most pure and clean water in our experiment. Another method to fix our project could be having more than one person with a stopwatch, so that we just made sure if the one person who was starting and stopping the time, if they had messed up, we had another source to make sure we got a reliable time. Lastly, we could have used a thermometer to take the temperature of the water, just making sure that we had a standard starting and stopping time, and not just looking at the bubbles to make sure that that's what we counted as the end boiling time.
So, to conclude, our research does not support the null hypothesis, which is that adding salt to water makes it boil faster. If you want to boil water as fast as possible in terms of this experiment, it's best to leave salt out of the solution. The water alone boils at an average rate of about a minute faster than the water solution with 3 tablespoons, and that solution also boils at about a minute faster than the solution with 5 tablespoons. Thank you.